Okay, we're going to rationalize expressions. So this is lesson 1.1. They've given us some steps on how to rationalize an expression. So for instance, if you have some number on top, say it's square root, and a root on the bottom, the goal is we're trying to get rid of the radical or the root on the bottom. So what we do is, if it's a setup like a fraction, we multiply the top and the bottom of the fraction by the radical on the bottom, or the root. When we do that, the root or the radical times itself will just become whatever term or number is underneath. And then top, you'll have the root or the radical of the two numbers multiplied by each other. Okay? Seems abstract. It'll make sense when we use numbers. Second process, it's pretty much the same idea. The only difference is on the bottom, say we have two terms instead of one. Here we only have one term we're dealing with. If we have two terms added or subtracted to each other, we're going to take the two terms, okay, and we're going to use the same radicals. The only difference is we're going to use the opposite operation when multiplying the top and the bottom fraction. So in other words, this one was a subtraction sign. We use the same two radicals when multiplying the top and the bottom of the fraction, but the opposite operation, which is an addition sign. I can explain what happens here, and I'm going to actually. I just decided that. Okay, and I'm going to use an example with numbers so that it makes sense to you. Essentially what you're doing is a system of FOIL. Okay, so let's pretend that we have root 5 plus root 2. Okay, and we're trying to rationalize this. So we decide to multiply by root 5, subtract root 2. This is very similar to a difference of squares. Okay, so if you guys remember your FOIL, that's root 5 times root 5. What's that going to give me? 5. Root 5 times negative root 2 is just going to give me negative root 2 times root 5. I'm not going to equate that. Then we have positive root 2 times root 5, which is going to be positive root 2 times root 5. And finally, root 2 times negative root 2 is going to give me negative 2. Well, if we look at our like terms, the two terms in the middle are going to create a 0 or cancel each other out. So we're just left with 5 subtract 2. Now I'm not going to equate that part. The whole point of it was to show you that our A term, which is 5, and our B term, which is 2, end up being the two terms subtracted by each other in the end. Okay? So we don't actually have to write out those middle terms. We know they're going to cancel each other out when we use the opposite operation. And that's the whole point of using this opposite operation, is so that our middle terms cancel out and we're only left with two terms once again. So let's actually do a question. First example in your book says to rationalize this expression. We're going to do it in black here. 3 over 4 root 5. How many terms are on the bottom? 1. Even though there are two numbers, because they're multiplied by each other, they're considered one term. So if we're going to rationalize this, we take the same term that's on the bottom, okay, and we're going to multiply it by that same term. So we have 4 root 5. And we're going to do it to the top and the bottom of the fraction. So when we do it to the bottom of the fraction, we end up with 4 times 4, which will give us 16, multiplied by root 5 times root 5, which is 5. I don't know why I'm writing that up there. It should be at the bottom of the fraction. Okay. And 3 times 4 times root 5, well, 3 times 4 is 12. We don't quite know what root 5 is yet. And 5 times... Did I do that properly? Oh, I multiplied by 4 root. That's fine, it works out in the end. This gives us 50, is that 80 on the bottom? Yeah. 80, 12 root 5. Okay. Now, if you notice in the book, they did this a simpler way. I apologize, I actually made it a little more difficult. When they multiplied it, all they did was choose to multiply by root 5. I'm going to show you how we get the exact same answer. They end up with 3 root 5 on top. 4 times 5 gives us 3 root 5 over 20. We have the exact same equivalent fraction. The only difference is if I divide the top and the bottom of this fraction by 4, my 12 then becomes 3 root 5. and my 80 becomes 20. It's the exact same thing. We just had a different scalar, you could say, of it, right? Just like when we were doing vectors. We're going to skip to the next one without even stopping. The next example they've given us is when we have two terms on the bottom. And in this one, example 2, they have the number 2 on top. And the two terms they have on the bottom are root 6 plus root 3. When we have two terms, if you remember, we're going to multiply by those same two radicals. The only difference is going to be that we're going to use the opposite operation when we're multiplying. So we have root 6, and instead of adding, we're going to subtract by root 3. And we're going to multiply the top and the bottom of the fraction by both of these. When we go about doing that, on the bottom of our fraction, okay, we know what it's going to create. We don't have to use the distributive property or FOIL. We know that we're going to have whatever term is underneath both of the radicals, which is 6, and subtract it by whatever term is under both of the radicals, 3. Okay? If you had distributive collective-like terms, you would have came to the exact same conclusion. Then on top, okay, so we had 6 and 3 on the bottom. Now when we go to multiply the top, think of this, and we'll do it on the side like a sound calculation, as 2 times root 6 minus root 3. So we're using our distributive property. Okay? Well, when we go about using our distributive property, essentially we're going to have 2 root 6 minus 2 root 3. Okay? We could have just left it like this, where the 2 is factored out, which usually is considered a more simplified version of it. So I've kind of worked backwards there. But 6 minus 3 is the number 3, and that's it. We've got what we've got here. That's it. How are we doing for time? Let's go to another example. Why not? Example 3. They've given us a similar type question. This one is kind of like a combination of the first and second one. We have the number 5 on top of a fraction, and the denominator of the fraction reads 2 root 6 plus 3. Okay? Same idea as before. We have a 2-term denominator, 2 root 6 and 3. Because we have 2 terms and they're not both radicals, what we're going to do in this case is I'm going to multiply, or I'm going to keep the exact same expression, just change the operation. Okay? Now remember, we did in the very first question, we only really needed to multiply by that radical. In this one, it's going to be better for us if we use both terms. So when we go to multiply, exact same denominator as before, 2 root 6 plus, whoops, only difference being what? Minus 3, 2 root 6 minus 3. Okay. Now we know that technically the second term here isn't a radical, but that's fine. Okay. Because we want to multiply by this. If we were only multiply by 2 root 6, when I multiply by 3, I'm going to have 6 root 6. I'll still have a radical on the bottom. Okay? That's why we're going to multiply all the way across by this 3. We're going to use our difference of squares to eliminate any radical forms on the bottom. When we do this, on the bottom, we're going to have, we know we're multiplying our 2 by 2, so that's going to give us 4, times root 6 is going to give us the number 6. Okay? So that's our A term. And our B term is positive 3 times negative 3, which will give us just negative 9. So we're left with that on the bottom. And instead of putting a dot, we'll put brackets, since that's what we're used to seeing. On the top, distributive property again is going to give us 10 root 6 minus 15. Okay? 10 root 6 minus 15. On the bottom, we'll have 24. Subtract 9. What's 24 subtract 9? 15? 15. 10 root 6 minus 15. Can we break this any lower? We can factor the numerator essentially we've already rationalized the bottom of this expression. There's not much more. Unless they really wanted it in a simplified term, we could factor the numerator, the top number. We could factor out the number 5, which would leave us with 2 root 6 minus 3 all over 15. But technically, these are the same thing. Put an equal sign. There's no difference. The only difference is we've simplified the numerator a little better. Okay? And the last example from that one. They asked us to actually rationalize the numerator in this question. So this question is a little different. Example 4. Root 7 minus root 3 divided by 2. They ask us to do the opposite of what we were doing. They ask us to rationalize the numerator. It's going to be the exact same process. We're going to multiply the numerator and denominator by those two radicals using the opposite sign. The only difference is we're going to end up with some radical terms on the bottom. Okay. When we do this, we're going to be left with 7 subtract 3 divided by, and again, we can leave the 2 on the outside of the brackets if we like, just because a factored form of this does tend to be a little simpler. 7 minus 3 is going to give us 4 over the same denominator, 2 root 7 plus root 3. And then from here, now because this is all multiplied by, this is where factoring it does come in handy. Because both of these terms are multiplied by 2, I can take this 2 and simplify the 4 or divide the 4 by it. So 4 divided by 2 will give us the number 2. So on the bottom, there's no longer a number to distribute. We'll have 2 on top because 4 divided by 2 is 2. And on the bottom, we're just going to have root 7 plus root 3. Now this tends to be counterintuitive because normally we rationalize the denominator, but it's fine. They asked us to do something different and we were so smart that we did it.